Okay, so as this comes up on the board, this is what we're doing today. What we are doing is kind of something that we alluded to last week on one of the homework assignments, where we're going to do one transformation, and then we're going to take that and do another transformation on top of that. So we're going to take one shape, and we're going to transform it twice. Okay, so you could actually do two or more, but we're just going to do two. So all of ours will be just two. Okay, so a composition, this is what it's called, a composition of transformations is when two or more transformations are combined to form a single transformation. Because if we're being honest, just doing one transformation isn't typical. Okay, so what happens is there's usually more than one, and it's used a lot in animation. One of my favorite examples of like multiple transformations, and this is kind of like where this goes. It's like the calculus of transformations, right? Is where this goes is in an animation. Have you ever seen Mulan? Anybody ever seen that Disney movie, Mulan? Okay, so there's a scene in Mulan where like the Hun army comes up and over the mountain. Did you know that that's actually only like 3 or 4 people that they created, and then they just duplicated it like 100 times? Right, to make that scene. Well, that duplication process uses transformation. So all sorts of animation and all sorts of different computer softwares talk about different transformations. You move things all the time on the computer, and to tell your computer how to move things is a good place where you can actually see transformations happening. Okay, we have one very specific composition. So this is a composition that has a special name. Okay, that's a special name for a specific type of composition. A glide reflection, and we're not super great at naming things, right? So a glide just means I'm going to move it over. Okay, so that is a translation. And then I'm going to follow that up with, so that's the glide part, and then the reflection is just a reflection. So if I do a translation and then a reflection, it's called a glide reflection. Oh, I have him maxed out. Okay, I'll just keep it. Thank you. But the more specific thing I'm going to add onto this right here is, and it'll say this a little bit below, but this reflection has to be parallel to the translation vector. Okay, so if you drew out the translation vector, the line that you reflect over is going to follow that same path. And we're going to do one of those so you'll see what I mean. We're going to start with just one point and show you what that looks like, and then we'll do a whole shape. And we're only really going to do 2 compositions because basically this is just doing everything we did last week, but doing one and then another. Okay? So the glide reflection, we're going to show what a glide reflection looks like. So a glide reflection is a transformation in which every point P, so we're going to give the point P the points 4, 5. Okay, so let's graph 4, 5. That's our point P. I'm going to see what this looks like. So this is P. Okay, now the final answer for P double prime. So notice that has 2 of those tick marks on there. That's called double prime. That means you're going to do 2 things to it before it gets to P double prime. So we are going to follow the 2 steps. The first thing we're going to do is a translation will map P to P prime. And the translation we're going to use is this one. We're going to use x comma y. So here's the rule for the translation we're going to use. Okay, so we're going to do that, and we're going to find P prime. Now this is a super simple translation because the lines that we reflect over are super simple lines. So I can't give you something super crazy like x minus 5 and y plus 7, okay, because of the fact that our lines of reflection that we are using are very simple. So we're just going to take this, and which direction am I going to go? Up, down, right, left? Down, yes. Down 6. So count down 6 and put a dot for P prime. 1, 2, 3, 4, 5, and one more. So we'll go here. So there is P prime. Okay, and then, so this is the whole idea of composition, is that I'm going to take and do one transformation, and then I'm going to take that P prime and do another transformation. So don't go back to P. Don't go back here. Go back to P prime. So take P prime, and then what we're going to do to P prime is we are going to take P prime to P double prime with a reflection. Now, I said that the line that we're going to reflect over has to be parallel to the translation vector. So the vector that we have is that line there. So whatever line we reflect over has to be parallel to that line in order for you to call it this special glide reflection. You could do any sort of reflection, it just wouldn't necessarily be a glide reflection. Okay, so this one is a glide reflection because we are going to reflect over the y-axis. So when we reflect over the y-axis is parallel to that original vector that we translated by. Okay, so to go over the y-axis, of course, is this line here. So you're going to count to that line and then count on the other side to find our P double prime. So 4 there, 4 there. And that's the basis of what we're doing today. Pretty straightforward, right? You're going to do one transformation, then you're going to do another. Okay? There's a couple more things that we'll point out as we go along, but let's go ahead and plot the example 1, and then if you are ahead, you can go ahead and plot example 2. We're just going to practice this twice, once with a glide reflection and once with non-glide reflection, and it's got that line y equals x, which we talked about last week, so we want to make sure we do that second example as well. Okay, so let's just go ahead and plot some points quick. If you want to jump ahead and actually do the translation and the reflection by yourself to see if you kind of get it, then go ahead. Jump ahead and go forward. Especially if you feel comfortable with all of the things that we did last week. You're just doing one and then you're doing the other. The trick is to not go back to the original shape after you have done the first transformation. Okay, so to do the translation, especially because we have a picture, and all of your homework problems will have a picture. So because I have the picture, I can just count. So this translation tells me to count 4 in the positive x direction. So the positive x direction just means I'm going that way, 4. So really all I have to do is take all of the points and count to the right 4 and make new points. 1, 2, 3, 4. There is my new P prime. my new Q prime. R prime. Okay, so I just slid that to the right for. That's what translations are. It just slides one way or the other. And then we're going to reflect that over the x-axis. So you kind of saw this last week as well. So what's going to happen is all of these points are going to flip-flop over the x-axis. So this shape is going to turn on itself upside down. So there will be some overlap. Okay, so because we're flipping this over the x-axis, which is right here, you are counting to that green line and then counting onto the other side. So this is going to flip over itself. Okay. Now, especially on these particular glide reflections, if you wanted to, would you really have to graph the original PQR? No. You could, if you wanted to, just add 4 to the original coordinates and graph P prime right away. So if there's too many pieces for you, too many moving pieces on this, too many things in the picture, you can just skip right away to graphing the first image before you get to the double image. Okay, so when I graph this over the axis, we can go 1, 2, 1, 2. There is my new Q double prime. Now from R, 1, 2, 3, 1, 2, 3. This is R double prime. And then P. So looks like 6. So we'll go to -6. Did I say on the same line here? Yep, there we go. P double prime. And then connect those. Okay, and there it is. Okay, now for some people, that's a nightmare. Okay, if you're not a visual person, that's a lot of lines and a lot of dots and a lot of craziness, right? So we also do have the rules again. So let me right here in this space, write your reflection rules for the x-axis and the y-axis, just in case, okay? So your reflection rules, because you do not have to do this visually, right? You're going to get those on the test. You're going to get these rules. So if you want to use the rules today instead of using a picture, that is perfectly acceptable. Okay, so these are the rules that we're going to write down. We're going to write down the x-axis reflection, the y-axis reflection, and then I am going to write down this one as well, but it'll be on the next problem because that'll show up. So I'll write these two in the space where we're at, and then we'll also write down the rotations if you want those as well. Okay, because you will get that on the test, so if you want to practice that today, you can. Okay, so our reflection for the x-axis. So our x-axis reflection changes every x, y, 2, and they use AB on the theorem sheet. We can use x and y. So the x-axis makes the y-coordinate negative. And then if you flip that around, the y-axis would make the x negative. So if you want those today and you don't want to do it by the graph or the picture, that is perfectly acceptable because you're given these rules on the test. You can practice that today. Okay, so those are the rules for the x-axis and the y-axis, and then we'll write down the other rules. You'll see those below. Okay. Okay, so this one right here, we're going to reflect this, and I'm going to show you this on the graph because, again, if you are a visual person, you're going to like doing the graph more. If you're not, I can give you the rule for this as well. So let's show it on the graph. So the line y equals x is the line that goes right through the corner of this quadrant, right? It goes up 1 over 1. Starts at 0 and goes up 1 over 1. Okay, so it's going to go right through the corner. It's a diagonal. So that is the line that we're flipping over. right there. The line y equals x. That's the line that we're counting over. So when we did this before, it's when you count to the line and then count onto the other side, you are counting diagonally, okay? So visually, let me just show you that right here. So we're going to count from this dot to this line. So it looks like that's half a box, right? So it's half, it goes right in the middle of that one, so we're just flipping that onto the other side. And right there would be our n prime, right on the other side. Okay, so this right here, this distance from n to this black line is half of that box, so just go onto the other side. And there is your n prime. Okay, so if you're looking at this from the actual coordinates, the original coordinates were 3, 4. The new coordinates are 4, 3. So if you are reflecting over the line y equals x, the x and y actually just switch position. Okay, so if you want that rule is on the theorem sheet, but if you want to practice that today and not do it visually, you can do that. You don't have to graph it at all. We just want the final coordinates after the two different transformations. Okay, let's count this one. So this one looks like I'm going to go a full box and then a half a box. So I'll go a half and then a full, and I'll end up right there. Or you can just flip-flop around the coordinates, and I'm going to end up at 1, -2. So there is your m prime. So I counted a full diagonal and then a half, and then a full. Okay, this is where it gets to be a little bit tricky. The glide reflections are pretty straightforward in the coordinate plane. This is where it gets to be a little tricky because now I have to rotate this 180 degrees. Okay, so which one am I rotating? Make sure you are looking, when we flip this paper, make sure you are looking at n prime and m prime and not the original orange segment. Okay, so I'm going to flip this upside down to rotate 180 degrees. Okay, and now we have to read ourselves the new coordinates without looking at the numbers on the graph here. So I'm going to go -1, +2, so I'll write that off. -1, +2. Write that for myself there. And then it looks like I'm going to go -4, -3. -4, -3. Okay, so the rules still apply. If you want to just turn your paper, you just turn it either 90 degrees or 180 degrees or 270 degrees. And that is the new coordinates that you can graph if you want to see this visually. So I'll go -1, 2. And I'll go -4, -3. So this one especially, you will see that it gets kind of messy. Okay, when you're doing multiple, sorry, that's way at the top there. When you're doing multiple transformations, okay, this is going to get kind of messy. Oh, I labeled them wrong. Sorry, this is our m double prime. This is my n. Sorry. There you go. And so it gets a little bit confusing as well. So the rules might be nice. So if you didn't write down the rules, you might want to write them down just in case. Okay, you're only going to do a couple of these, and you're at some point with the rotations, it can get kind of overlapping and kind of crazy. Go ahead, Aiden.
Is the 180 rotation a double prime?
Yes. Mine 1, 2, and then there's 1, 2 there. So I'm going to write down the rules here. Go ahead. What was your question? What's the rules? Was that your question? Okay, so there's 3 rules. We have a 90-degree rotation. And I'm going to write down all of them here. Obviously, we didn't do a 90-degree rotation, but this way you just have them. Okay, so the 90-degree rotation is going to take that y, bring it to the front and make it negative. And you don't have to use these, and you don't have to use the graph. You can choose whatever method. works best for you. So if you kind of notice with the points that we had there, we started with 1, -2, and that changed to -1, -2. So it's actually -x, -y for 180 degrees. They don't switch position. They just switch their sign. And then the last one is a 270. So you can have those there for reference if you want them, or you can use them if you think, wow, that's a lot easier than drawing it out. Okay? Go ahead.
Will it ever throw us off and say 70?
No, we actually can, because we know how to do sine, cosine, and tangent, we actually can do rotations. We just don't have time to dive into that. So that's actually something you will do in pre-calc. If you take pre-calc, you will do degree measures that aren't nice, like 70 degrees or 110 degrees, and you'll talk about reference angles to the x-axis and all that good stuff. We just don't have time to do that. It's a good question, but no. The answer is no. You won't see anything like that. Okay, so I'm going to give you the homework assignment, but you're only going to do the front page. The back of the homework assignment, we're actually going to add to our notes for tomorrow because it's good information, but you won't be tested over it. So I'm going to give you this, and you're only going to worry about the front side today.